Good afternoon, everyone. My name is Eduardo Nascimento, and the purpose of today's presentation is to talk about a family of natural language interface tools based on ChatGPT and LangChain. Here we have the topics. I will introduce the subject, then I will talk about some features of ChatGPT and LangChain. I will show the experiments and their results, and then finally the conclusion. Introduction. The large language models came to the foreground with the announcement of conversational interfaces, such as ChatGPT, that generate high-quality textual answers among other tasks. LLMs offers a possible strategy to simplify the development of natural language interfaces for database, NLIDBs. We identified an NLIDBs family that uses ChatGPT and LangChain features to compile natural languages NL sentence, expressing database queries into SQL code, and extract keywords from NL sentence, which are passed to a database keyword search tool, KWS. I will do a summary of the required ChatGPT and LangChain features. Many people are using ChatGPT in their web interface to perform specific and often one-off tasks. However, there is an opportunity to exploit these tools through dedicated API calls to LLM. The OpenAI provides the chat completions API that takes a list of messages as input and returns a model-generated message as output. In the figure, we have how to create a chat model to use in an application. We call the chat completions, passing the model, the temperature, and the messages. The prompt. The prompt is a list of messages that contain instructions or questions that the user gives ChatGPT to respond. Each message in prompt comprises a role, system, user, or assistant, and the content. The system role sets behavior of assistants. We defines the assistant behavior from specific instructions about how it should behave during the conversation. The user role requests or comments the user roles provides requests or comments for the assistant to answer. Finally, the assistant role refers to response from ChatGPT. ChatGPT can translate NL queries into SQL code. To translate, we configure the system behavior to generate SQL through the system role, and we send the query in natural language in user role. The models perform the translation. We may pass the information about the database schema manually, like in this example. However, imagine pass information manually from each database to the translation. It would be very bad, right? Thus, there is LangChain. LangChain is a framework for developing applications powered by language models. LangChain provides the chain interface. We define a chain very generically as a sequence of calls to components, which can include other chains, to execute a task. And we can use LangChain with Python and JavaScript. How to translate NL queries into SQL code with LangChain and ChatGPT. LangChain extracts information from the database automatically, creates a prompt with context information about database schema, and passes this information to ChatGPT. In the figure, we have an example of how this translation is done. First, with which tables to inspect. After, we connect to database using SQL database. The chain named SQL database chain inspects the schema, tables, columns, joins, and then provides to ChatGPT with this information automatically. We can also manually add a prompt with LangChain. So ChatGPT constructs SQL code from NL carrier and user, which is then executed and returned by LangChain. Another task we can do is to extract keywords from NL sentence. It's similar to the translation to SQL. We configure the system behavior and pass the query natural language. We can provide sample queries with expected response using assistant and user roles. Another interesting feature is that we can describe functions for ChatGPT to do some task and it responds with the signature of that function. This is done passing two parameters, a function calls. The functions where we describe what the function is, and the function call defines whether ChatGPT decides or not to call the function. This feature provides a straightforward way to create an NL front-end to a database keyword search tool. In these figures, we are describing a function that receives keywords extracted by ChatGPT. We provide the function name and description, search keywords, send keywords to keyword search tool, and function parameters. The function parameters in this case is the extracted keywords and their type is string. And the model responds with the signature of the function and the arguments, in this case the extracted keywords. The experiments. In the process of exploring ChatGPT features to build NLIDBs, we identified two alternatives. The SQL alternative translates NL queries directly into SQL code, and the KWS alternative uses ChatGPT to extract keywords from NL query and then uses a KWS tool to find the answers. In SQL alternative, we have 4 options. Option 1, we use the knowledge embedded in the LLM with no context to generate SQL statements. We call ChatGPT SQL. Option 2, ChatGPT SQL prompt fine-tunes the model by manually passing the main terms of the schema, table, columns, joins via prompt messages. Option 3, ChatGPT SQL LangChain fine-tunes the model by automatically passing schema information. Option 3 and Option 4 use LangChain. Option 4, ChatGPT SQL LangChain prompt fine-tunes the model by automatically passing schema information via LangChain, and we add more information manually via prompt. In KWS alternative, we have 2 options. Option 1, ChatGPT KWS uses the knowledge of the model to directly extract the keywords. And Option 2 fine-tunes the model by passing the main terms of the domain as well as examples of NL queries and their translations to keywords via prompt or list message list. And more specifically, in KWS alternative, we show how this approach works. We created an application where, giving a natural language query from an user, the ChatGPT extracts the keywords. The application takes the ChatGPT response that comes with the function signature and the arguments and runs the function. In the function is where KWS is called, which searches for data in database and returns to the application. The application sends the results to ChatGPT to show in natural language. We use data from the Mondial database to do the experiments. And we manually created a ground truth with 27 queries in natural language and their expected keywords. Results. We have here in approach ChatGPT SQL, where no context is given, some results. In this case, they all failed. At first, an error occurred in the generated SQL. In the second, ChatGPT did not generate the SQL and answer the question on your own. In the last, ChatGPT did not generate SQL and apologize. I'm sorry, but I'm not able to provide the SQL equivalent of the given text as it does not involve a SQL query. And when we passed context information about the schema, it was able to generate valid SQL queries on some that were run on the database. And in other queries, they did not run in the database. The same happened with the approach with LangChain, but we highlight here that in some queries it put quotes in the column names and generate an error when executing database. So we resolved this by adding prompt manually with more information. For example, don't use quotes in column names. But in some cases, it generates wrong queries. For example, tell me about the Caribbean economic. It generates Caribbean as a continent. Here. The KWS alternative, where no context is passed, it was able to extract the keywords, and KWS was able to return the search results. Finally, ChatGPT shows in natural language. In example, what is the area of the city Granada in Nicaragua? The extracted keywords from ChatGPT, KWS answered the query, and ChatGPT responds in natural language. But in some cases, KWS did not bring results with the keywords extracted by the model. For example, what's the total number of seats in Cuba? The extract keywords total number of seats in Cuba. The KWS answer didn't answer the query. In this case, ChatGPT extracts cities and KWS could not handle the plural form of the city. Already passing a prompt with information to structure the model, it succeeds. For example, what's the total number of cities in Cuba? The extracted keywords was total, city, and Cuba. The keywords search answer the query, and ChatGPT show the response in natural language. But in some cases, ChatGPT did not extract the keyword as expected, and KWS returned an incorrect result. For example, what's the host province of the International Energy Agency? The extracted keyword was Organization International Energy Agency. But in this case, ChatGPT was unable to extract the keyword province expected in the ground truth. Comparing the results, there were failures in all cases to generate the SQL without passing information. In fact, the model had no knowledge of the schema. It was better at generate SQL with schema information passed manually than using LangChain in an automated way. But it would be really bad to do this for each database schema. And finally, in KWS alternative, there were more corrects than fails. We have that providing a prompt with instructions was the best performance. And the conclusion. The experiment suggests that ChatGPT KWS prompt, which uses prompt with context information and examples to help extract keywords, is the best performing NLIDB. Extracting keywords is far simpler than generating SQL code, but the extracted keywords might not be the expected one. To summarize, the use of ChatGPT reduces dealing with NL queries to a few-shot learning process for the benefit of developers interested in creating NLIDBs. This work is in a Git repository in this link. The reference, and that is it. Thank you for listening.